Yo, what's up, you chemistry nerds? So I promised I would make a review video for you, and here we go. I'm going to try to do this. So what I am hoping to do with you right now is go over a couple questions from the August 2015 chemistry Regents. However, the multiple choice, I'd actually like to skip that for now. What I really want to focus on, at least for now, I'll go over the multiple choice in another time, but I'd actually like to go over kind of harder part of the test, which is the part two question, or really part three, which is the written response question. So I'm going to go over these and let's see how we do. All right. So this first one says determine the vapor pressure of ethanol at 90 degrees Celsius. Okay. So this question requires that we use the reference table, but they asked about vapor pressure. So this is going to be reference table G, I believe. Let's see. Oh, went way too far. And now here's the annoying thing. Counterclockwise. There we go. I have to flip the reference table a couple times. Table H, not G. Okay. So here's table H, the vapor pressure of four liquids. And basically, let's go back to the question. They asked us, what is the vapor pressure of ethanol at 90 degrees Celsius? So what we will do is go to the graph for ethanol and find 90 degrees Celsius, which apparently is right about, oh, sorry, I got to get this out of the way. Okay, yeah, I got you. Okay, 75, 80, 85, 90. So there's about 90 right there. So we go up from, oops, not a straight line, but if we go from 90 degrees Celsius across to the vapor pressure, the vapor pressure of ethyl alcohol at 90 degrees Celsius should be about 150 kilopascals of vapor pressure. So let's see, is that the answer? So we're going to put, I guess we could, let's try writing this. No, not highlighter. Pen. I like green. Let's go with green. Cool. So this should be 150 kilopascals. Now, of course, I'm going to scribble a couple of answers on here, but really there is an answer booklet. If I have to open the answer booklet, I will do that to write some answers on there. All right, let's keep going. So explain in terms of particle arrangement. Okay, so here we go with one of these questions. In terms of something. So basically, if you don't mention what they asked you to mention, you are not going to get any credit. Okay, so we have to mention particle arrangement. Kind of like think about how somebody can ask you, how is your bedroom arranged? It's where everything is. Okay, so it says, why is a sample of solid sodium chloride, which is table salt, has less entropy than a sample of aqueous NaCl, which is dissolved? Okay, so here, time for a note. Oop, wrong program. We'll go to this. So here's a definition. Entropy, excuse my horrible handwriting, but entropy is a measurement of disorder, like messiness, right? Disorder, not order, disorder. So basically, let's think about this. If you have a solid, the particles are, very arranged. Well, they're supposed to be in a true solid, like ice or a diamond, a crystal, right? So you would look at a solid and the particles are very arranged. So the disorder is actually low because they're very orderly. So you would say that this has low entropy. Let's think about a liquid. If you have a container of a liquid, the particles are kind of stuck together, but not organized. So liquids have, let's say, medium entropy. Cool. Now you could probably guess gases. Let's say we have a box with a gas. The particles are totally separated. They're randomly, there's no arrangement at all. They're all over the place. So gases have high entropy because they're very disorderly. Now, the question asked about aqueous. Well, you all know what aqueous means. Aqueous means when something is dissolved. So let's see. Maybe I could find a model that will help with this. Probably something you've seen before. Do they have solubility? Oh no. They don't have the solubility. Oh, aqueous. Nope. Acid-base solutions. What about states of matter? Oh, that's only about solid, liquid, and gas. Okay. Well, basically, you all know what aqueous means. Aqueous means that you have something dissolved in water. So let's go back to our diagram. Okay, so let's say we have a solid piece of table salt. Okay, so solid, low entropy. Let's drop it into some water. So here's aqueous. Okay, so let's take our solid table salt and drop it in water. And we know that if we take table salt and dissolve it in water, what happens is the sodium ions split apart from the chloride ions. And basically, you have a bunch of positive and negative ions floating all over the place, not orderly like a solid, when you dissolve a ionic compound like salt in water. Which, by the way, don't forget, that's why this is called an electrolyte, because salt water conducts electricity because there are ions floating all over the place with electrical charges. So, electrolyte. Okay, so now let's go back to entropy. Think about solid table salt, which is nice and orderly in a crystal, and then you have dissolved table salt, which is very messy. So aqueous mixtures of things dissolved in, let's say, water have higher entropy than the solid. So greater entropy when something is dissolved. So now we can answer the question. Explain in terms of particle arrangement why a sample of solid table salt has less entropy. Okay, well here, you know what? Because my handwriting stinks, I will type up the answer. So this is question 52. So to save you some sore eyes with my horrible handwriting, I'll type it up here. So solid table salt has less entropy because the particles are more orderly, or you could say are arranged more orderly, anything like that. So are more orderly or arranged more orderly than NaCl aqueous, which you can also, instead of saying aqueous, you could say more orderly than NaCl dissolved in water, etc., anything like that. Okay? I hope that makes sense. Let's try the next one. All right. So 53. Determine the molecular formula. Okay, so we got that molecular formula. For a compound that has the empirical formula CH2O. That's the empirical formula. I'll go over what that means in a second. And a molar mass of 120 grams per mole. Okay. So first, let's go over what empirical formula is. So I'm going to ditch all of this piece. Okay. And I'm a weirdo, so I want a different color now, different topic. Okay. So let's go over empirical formula. Okay, basically, empirical formula just means what is the most basic ratio between the elements in a compound. It's kind of like if you have a basic recipe for pancakes and the basic recipe says, okay, for 10 pancakes, you need a cup of water, 1 cup of flour, half a cup of milk, and a little bit of butter. So if that's the basic recipe for 10 pancakes, if you wanted to make 20 pancakes, you would just multiply the recipe by 2. So similarly, let's go with this. Like glucose, you probably remember from living environment. So glucose has the molecular formula. So here, ready? So the molecular formula, my C and my U look similar. Molecular formula, which tells you actually how many atoms of each element are in the molecule, which is why they call it the molecular formula. So glucose is C6H12O6. So that means there's 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. But here's the thing. If you divide by, well, let's look. You could divide all of those numbers by 6. So now you'll get the most basic ratio of elements, which is called the empirical formula. And if you divide all of these by 6, you get the empirical formula, which is the basic ratio of elements, which is C H, so 12 divided by 6 is 2, and 6 divided by 1 is 0. So now if you check it out, the basic formula for glucose, the empirical formula, is CH2O, which, by the way, is why glucose, which is a sugar produced from plants through photosynthesis, they're called carbohydrates, because look at the formula. It's carbon with water, which is hydrate. So you have carbo, and you have water, which is hydrate. So that's why sugars are called carbohydrates, including starches. There we go. So back to the question. So let's see. They give us an empirical formula of CH2O. Oh, look at that. CH2O and a molar mass of 120 grams per mole. Okay, so what about the molar mass? So that's the mass of all the elements added up in the chemical. So let's see. Let's see, we'll leave that there. We'll keep going. So they gave us the empirical formula. Look at that. Didn't even pay attention to that. CH2O. And the molar mass is 120. So you know what we're going to do? I'm going to find the mass of this. So CH2O. So I'm going to go to the periodic table. Let's ditch all of this. Erase. Yeah, erase. Oh, goodbye. Can I erase all at once? I got to try that next time. Okay, so let's see. So now I want the periodic table. All right. That means I'm going to have to rotate this thing. This is tons of fun. Clockwise. Okay, so CH2O. Okay, so let's look. So carbon's mass is 12. Oxygen's mass is about 16. And hydrogen's mass we know is the smallest. It's 1 at the top left. Don't forget, the atomic mass is at the top left. Okay, so we have CH2O. So we have 1 carbon, 2 hydrogens, and 1 oxygen. So let's add that up. So we've got carbon, which has a mass of 12, hydrogen, which is a mass of 1, but there's 2 of them, so I'm going to multiply by 2. And then oxygen, there's only 1, and the mass is 16. So if I add those up, that's 16 plus 12 is 28, plus 2 is 30. So if the mass of the formula is 30, and they said that the molecular mass of this chemical is 120 grams per mole, 120 divided by 30 is, well, here, check this out. Remember this math trick? You could cancel out the zeros, and then 12 divided by 3 is 4. So basically, now that I know that this substance, this compound, must be 4 times as much as the CH2O, the basic carbohydrate formula, now I'm just going to do this. I'm going to distribute. So 4 times 1 carbon, so that's C4. 4 times 2 is H8. And 4 times 1 oxygen is O4. There we go, C4H8O4. That's the answer. That is the formula, C4H8O4. And by the way, I believe that's another, is that ribose? Let me check. C4H8O4. Yeah, which, is this ribose? Erythrose, threose. It's some other sugar. It's another carbohydrate. If you notice, the names always end in ose if it's a sugar, which is a carbohydrate, or a starch. Erythrose. Yep. There we go. C4H8. It's a light yellow syrup. Interesting. I wonder how it tastes. Probably sweet. All right. I'm going to continue in another video because I think I could do an even better. But tell me if this helps you or not.